fun. All right. Well, welcome once again to Astronomy Daily Live. Oh, you know what? I'm gonna rotate this a little tiny bit, just like that. Yeah, that's a little better, because otherwise it looks out into the darkness, and there might be a little bit of a problem with the contrast there. But hey, all right. Well, welcome everybody. Welcome again to Astronomy Daily Live. I've got a little bit of coffee left in here, a little bit of coffee. So cheers to that. And I've got the hydrogen hydroxide, HOH, a nice balanced molecule. All right, nice balance. I forget what the angle is. The angle is between the hydrogen atoms and the oxygen atom. I think they say it's something like 105 degrees, or I forget exactly. We'd be able to find out. But anyway, cheers to all that as well. I hope everybody's doing well today or tonight or this afternoon, or wherever you are on this very, very likely to be a sphere of a planet. So cheers. Hope everybody's doing well. Everything's good here. Just sort of a normal day. Nothing extraordinary or anything. Cloudy, warm. It's actually I almost want to take this off. Almost. So pretty nice. In contrast to sort of the rest of the country that is definitely under a deep freeze. So pretty amazing. Hope everybody stays warm where you are. It's never all that fun, to be too cold at least. So hope you're able to stay at least moderately comfortable wherever you are. So yeah, very cool. I'm gonna open up the chat here, make sure that everything is good there. Hey there, Justin T. Nice to see you in the chat. Saw you a little bit earlier, so good. Very, very good. Yeah, feel free, to come into the chat as long as it's there. You can come in anytime. I try to set up the event for this live stream by about 14 or 15 hours UTC or so. I try to get it all set up by then. That doesn't always happen, but I definitely try. So when you notice that it's there, come on in. Feel free to have any kind of conversations you wish. I don't check on those things all that often, because, well, I'm usually going off to the day job after that, and so I don't really check in on those things until I get home in the evenings here. So in southeastern Arizona. So, all right, well, cool. Well, glad everybody's doing well. I want to say hi to Bobby on the panel once again. Hey, what's going on?
Not the much. Same old. Got the faucet water.
All right, cool. Very, very good. Very good. Yeah, I've I don't know why. I've always gone to this first. Right? Given a choice between various things, it's like, give me some of this, right? This is really, really nice stuff, on a hot day when you've been working outside all day, say, doing yard work or whatever, right? And it's hot and you're tired and everything else. Greatest thing in the world is to come into a big mug of this cold. It's like, awesome. Very, very awesome. Yeah.
And there's Chris Elliott from Elliott Astro Imaging, Andy Cowley in the chat.
Hey there, Chris and Andy. Hey, nice to see you. Excellent. Hope everybody's doing well out there. Like I
And
said, you know.
Tim Robinson won't be joining us. He is like have to go to bed early and rise up early.
Oh, all right, yeah. Well, you know, Tim is over in the UK as well. I think that's where Andy is, if I remember right. So yeah, yeah, definitely. You know, and that's one of the really cool things I think about this daily live stream, right? Is that you know you can pop in here anytime you want, any day, and you know if you want to watch it later on as well, that's okay too. I don't know how. I don't know how. You know, um, I'm not sure if these live streams are quite as good when they're not live. Although I do get quite a few viewers, you know, who watch these live streams later. So yeah, I guess you know I'm not one, you know, to judge those kinds of things. So you can feel free to come in anytime you want, any day. Like I said, you know, my primary thing is to try to be here every single day at 2 hours UTC. It doesn't always happen. It doesn't always happen, but I think I've been relatively consistent. So I think that's probably, you know, the most important thing. So yeah, so 2 degrees Fahrenheit at Chris's location. So uh, yeah, that's you know, well, it's winter time, right? I mean, in the northern part of the planet, it's winter time. That's sort of what one expects. So yeah, just you know, hopefully you're moderately prepared. You know, we've been experiencing, well, we not me, but some of us
And
have
I'm actually in the
you know.
hottest by 1 degree. Like yours is
Oh yeah.
56, I'm 57, and he's at 2.
Let's see if mine has changed in the last couple of minutes. I doubt it, but we will look one more time. We will consult the Weather Nightbot and see. Weather Nightbot's being slow. Come on, here he is. Now it's 54. Ooh, man, yeah, it's just a freeze. Horrible. so yeah. Well, you know, Chris, don't be jealous. I think you know, most places are nice, and you have to deal with things, right? You have to deal with things. Some of us have to deal, you know, with more things than others. You know, my location here is pretty benign, not too exciting. Doesn't get really cold. Doesn't get really hot here. You know, most people say, you know, that um, the state of Arizona, you know, gets really hot and and all that. Well, not where I am. Right, I'm at an altitude of about 4,500 feet, and it will break 100 Fahrenheit for a few days a year, but usually not that much, right? And a couple days a year, it'll get into the single digits, right? Um, but again, that's not too bad, right? So
Right, welcome, Patrick Beatty. Patrick Beatty, try the zip code function, not just because I don't think the my way I recognized it.
yeah, either that or maybe just the city name. That that might do it. Yes, that's almost a mile up. It's almost a mile up. So yeah, I mean it's very bit different here than like Tucson or Phoenix, or actually even points west of that, Death Valley and all of that. It can be a cooker out there, right? Which I also like, right? I mean, I really like. When I first moved to Southern Arizona, I lived in Tucson, and that first summer I was here, they were right in the middle of a heat wave where it had been over 100 degrees Fahrenheit for like the past 30 days, and it broke 110. I think it broke 115 a few times, and oh man, I loved it. It was absolutely great, absolutely great. So there's a date in Tennessee and a date in Florida. Yeah, Patrick, try your zip code. That'll probably nail it down. Yeah. It just doesn't like you. Yeah, that's Nightbot for you, right? So cheers. Cheers anyhow. All right, well, cool. Well, good. Well, I'm glad everybody's here. Welcome. Yeah, so, this live stream is all about the science of astronomy and space and, sciencey things in general. I want to keep it really casual, fun, laid back, no hurries, no rush, no nothing. Chelyabinsk, I guess. I don't know. That's that looks like a confused Nightbot. I wonder if you can do something like this. Let me try like Tucson, AZ. I wonder. Well, it'll probably pick up on just Tucson. So yeah, I don't know if that helps or not. It's always fun, to try to confuse the Nightbot. Dayton, what was it? Florida? Let's see.
Ohio.
I'm going to try the Florida one and see what it does. Like I said, I like to confuse these machines if I can. Oh, it said Layton. All right. Yeah, I think.
Try it with a comma. You did it with a period, Patrick.
Yeah, I think Nightbot is confused. So, all right, well, cool. Well, one of the things that we haven't done in a while, and I like to do this as often as we possibly can, is do an object of the day. So why don't we go ahead and do that? And I suggest that we do an NGC object, a new general catalog object, and we can let's actually let Nightbot choose it for us. It'll choose a random. Hey there, Ingrid. Nice to see you in the chat. Very cool. Welcome for coming in. Yeah, the Laytona 500. Yeah. Yeah, that's that new car race. Yeah, it'll be all the rage next year. So yeah, very cool. But yeah, let's let Nightbot choose our object of the day, and it's going to be an NGC object from the new general catalog. And the new general catalog has been around.
Welcome, Ingrid Asai.
Yeah. Hey there, Ingrid. Now, the new general catalog has been around for quite a while. I think it's evolved a little bit. It's probably grown. Excuse me. It may have changed over the years. Right now, there are 7,840
From
objects.
Brazil. Wow. Where you at from Brazil, Ingrid?
Yeah, yeah, from Brazil. Very cool. Yeah, that's a uh, you know, one of these days I definitely want to get to South America. Brazil's very, very big, right? It actually goes from north of um, the um, equator, pretty far south. Yeah, that is quite a spread. But yeah,
I Sao Paulo coast.
Sao Paulo, cool. Very, very
Hmm.
cool. Very nice.
Interesting.
Yeah, I definitely would like to get down there at some point. I want to see the southern sky. If I never do, yeah, maybe I'll catch it next time. Who knows? But yeah, yeah. If I'm ever given the opportunity, to go down there and see the southern sky, I would definitely like to see it. Now, from my location here in southeastern Arizona, I can see down to a declination of about -58 or so. All right, so that's pretty far south, but it's that last 30 degrees, right? That I just cannot see at all. So yeah, but
If you follow Oxford Shortwave blog, he recently went to Brazil and stuff. I think he was just heading home and stuff. It is home in Oxford, UK, and he did some good catches. He even caught some long wave, transatlantic long wave, and I think that was pretty darn good.
sweet, sweet, nice, nice, nice. Well, cool. Well, I am really, really glad that everybody's here. Let's do our object of the day. So let's let Nightbot choose the NGC object here, and I think I got a command for that. And let's see what it comes up with. Here we go. Bam. And we'll do a little bit of an examination of whatever this object comes up with. 2655. Okay, so this catalog is sort of ordered by right ascension, right? So the low numbers are around 0 hours right ascension, and then the higher numbers go up to 23, and then of course it wraps around again. Right ascension goes from 0 hours all the way around to 24 hours. 24 hours being actually back at 0, right? So the fact that it's 2655, we can get a pretty good idea in terms of right ascension where it is. Now, in terms of declination, don't have a clue. So this could be north, south, don't know. But 2655 divided by 7840. Whoop, I did that wrong. 2655 divided by 7840, then times 24. That puts it at about 8 hours, 7 minutes or so. So let's see how close it actually is. What I'm going to do is I'm going to share my screen, and we're going to go over to this great database called SIMBAD. That's SIMBAD. And this is hosted by a group in France. And SIMBAD has been around for a long, long, long time. I started using SIMBAD about 1990 or so. So it has been around. I mean, it's evolved, right? It's definitely evolved to what it is now. And at least according to this, which I'll sort of zoom in on here a little bit, this is SIMBAD 4. I guess I'm reading that right, for 1.7 May of 2018. So that's sort of its last. Oh, here's a release history. that might be interesting to sort of look at really, really quick.
I think being like 1 year old and stuff, and it's like that's kind of a bit crazy.
Yeah. Okay. So this only. Oh, all right. Well, we'd have to go all the way back. So I don't think I'm going to do that. I was hoping it'd be all on one page, but yeah. So I'm not exactly sure when Sinbad started, but it was somewhere in the late 80s, early 90s or so, right? And like I said, I mean, it's evolved, it's grown. And what they do is, they basically go through all the papers, all the journal articles, all the catalogs, everything else, and just extract information about all these objects. So you can get info on practically any astronomical object you want. Stars, galaxies, clusters, nebulae, all of that. It's all here. And but we're just going to do a basic search for our NGC object, which is 2655. 2655. Yeah, Chris has got a great channel as well. So definitely check out Chris Elliott's page, and Ingrid already has, it looks like. So good. Yeah, I think I said this on my very first live stream, and that is, this is a big universe, right? There is no competition at all. There is so much room for all of us that I think it's great. Some of us are going to last, and some of us aren't, and that's fine. There'll be new ones. I mean, I'm still new, right? I mean, I've been doing this just over a year, right? So I mean, I'm just a babe with all of this stuff. Anyway, so 2655. Let's go for it here. 2655. All right, so it is a galaxy of some sort. It's called an active galaxy nucleus in this case, which I don't know where exactly they come up with these designations. I'm not quite sure what a liner type is, so maybe we can try to find that out as well. But here's, just sort of the basic information, the celestial coordinates here. It is definitely in the north, right? So yeah, 8 hours, 55 minutes, 37 seconds, and then a positive 78:13:23. So let's see, that puts it, let's see, 8 hours. Wow, that puts it, that puts it maybe around Ursa Major or so, if I have my constellations right. So that's kind of cool. We'll try to find that out. Anyway, it looks like it's a pretty tight galaxy. An S0 or SA means it's a spiral type, but doesn't really have a lot of arm structure, right?
It does look like a nucleus. Well, I was looking at the Atlantis. I don't see any neighboring anything and stuff.
Yeah. Okay. Yeah.
Okay, I zoomed it out a little bit more, and I think there are some galaxies and stuff.
Cool. Well, we will definitely come back to that for sure. So here are the magnitudes, right? How bright they are using different colors, right? So they've put filters in front of their cameras and measured the brightnesses in at least these five different wavelengths: B, V, J, H, and K. B and V are sort of visible wavelengths, and then J, H, and K are more towards the infrared. And as you can see, it it actually gets really, really bright in the infrared, which is pretty typical for spiral galaxies. They, you know,
And it does look like a nucleus for sure. I was looking at this in bed myself.
well, an active nucleus just means that there's a lot of action on here. You know, that's sort of a specific term. So yeah, we'll come back to that for sure. So let's sneak down here. Of course, it has a bunch of different names. This is all exactly the same object, just different names, right? Which correspond, you know, to different catalogs, right? So a catalog or a survey has said, okay, we want to find all the objects that have, you know, certain characteristics, and if this object does, then it gets put into this catalog. And yeah, so a bunch of different names, not too surprising there. So wow, so lots of references. So this object has been very, very well studied over the years. So that's kind of nice. Well, what I like to do is I like to look at sort of the latest stuff and the earliest, and just sort of see, you know, what that shows. It's got a few distance measurements here, some velocities. So let's see how far away they think this thing is. So pretty good agreement there. You know, 20 to 23 megaparsecs. So that's million parsecs, and a parsec is 3.26 light years. So 3.26 times 10 to the 6th is a megaparsec, and then I'm going to multiply that by what sort of the average here, which maybe is like 21 and a half. So times 21.5. So that's about 70 million light years away. So, yeah, you know, relatively speaking, that's pretty close, right? That is pretty close. And that's, I think, at least one of the reasons why.
I think you eased the Nightbot about the links and stuff.
What did I do?
Because like usually if there's like a link and stuff like that, it usually gets thrown out.
Oh, well, Ingrid must be special. So, yeah, she got away with it. Very, very cool. Cool. We'll keep challenging that Nightbot for sure. So well, cool. Let's take a look at it really, really quick. Since we're here, might as well take a quick look. So this is one of Ingrid's friends. Cool.
And,
sweet. So yeah, of course it's all in that's probably Portuguese. So yeah, I would have to translate it, but wow, they've got quite a few subscribers, and yeah, I am definitely. Let's see, I can have Chrome. There we go. So Gallery of the Meteorite is how it translates at least. And I always like to look at all, you know, the videos and stuff. Cool. Yeah, I am going to subscribe. And
yeah,
I'm going to ring that bell.
Yeah.
Cool.
Yeah, it's Portuguese, but my friends speak English.
Yeah. That's cool. And, you know, I mean, even if there's a translation there, that's you know, fine with me. So so cool. But yeah, you know, greatly appreciated that you know, he speaks English, that you know, I don't think that that is really necessary. As long as there's a translation there, that's fine with me. So cool, nice. I will definitely check it out. He looks really popular. So cool, nice. Well, thanks, Ingrid, for that. So yeah, the fact that we can sort of see details in this galaxy typically indicates the fact that it's probably pretty close. So 70 million light years certainly isn't like right next door, but it's really not very far either. So that's pretty nice. And it looks like there's pretty good agreement in terms of how fast it seems to be moving away from us. If these numbers are positive, that means that it's moving away, right? So pretty good agreement there, maybe around like 14 or 1500 kilometers per second. So that's a pretty good clip. Might be part of like the Virgo cluster, which is a huge cluster of galaxies. But yeah, we'll maybe get into that a little bit as well. So yeah, let's look at the picture here, and then what I think that we should do too is go over to the new Pan-STARRS data release and see what kind of pictures are there too. Because they probably have this photographed in at least 5 different wavelengths.
I think in the Aladdin, I think you should be able to see it in the data release 1 variant. But I
see that. Yeah. Okay, well, we can definitely do that for sure. Now there's some interesting things going on here with this guy. You see all this stuff way out here. That's kind of interesting. I don't know if this is real or not. I don't know if you can see that or not, but there's a little fuzzy fuzz right up here too. So that's kind of cool.
Invite the welcome Astro Live channel in the chat.
Hey there, Astro Live.
Yeah, they got 2 variants of the Pan-STARRS data release 1. They got the CGG, and just C.
Right. I gotcha. I'm following you. Cool. So, well, nice. That's a nice looking galaxy. Let's look at the Pan-STARRS data release 1. Not quite sure exactly what. Okay, so I guess this is just from the Z and G bands, and then this one is just from the Z band,
okay,
right? So let's take a look and see. Yeah, here we go. Pretty nice. Pretty cool. Kind of funky looking a little bit, but that's how these things are. Let's look at this one too. Okay, that's pretty much back where it was. Wasn't that what we were just looking at? Anyway, yeah, so, seeing a lot of stars, right? And all of these stars are actually foreground stars, right? These are stars in our galaxy. And, we're sort of looking through those, past all of those, to this guy way out here. And yeah, there's another one out here. Now, assuming that intrinsically these 2 galaxies are the same size, I would say that this guy is further away, right? Because he's smaller, right? That's how perspective works. Things that are further away seem to be smaller, even though they may not be. Now, this galaxy might be actually that small, and this same distance as this. Don't really know, but I think it's a pretty good guess. Ooh, here's another one here, that this guy's probably pretty far out, and he looks like some kind of funky spiral of some sort. It's got some weird things. Maybe this is a galaxy even further away. It's kind of hard to tell, right? I mean, it's getting a little fuzzy there. And then, yeah, we saw another friend down here. So you see how NGC 2655 is pretty round, right? Well, this is a spiral galaxy, which is face on, right? So we're looking at it like from the top or from the bottom, depending on your perspective there. So this guy is also a spiral, right? But it's sort of set at an angle, right? So, it's also most likely pretty round, but because of our perspective, we're seeing it sort of at this angle. But we can definitely see here, some spiral arms, some probably star forming regions. Pretty busy place. Nice nucleus there. It's got some nice color to it. Let's look at it with this one too. So yeah, pretty nice. Pretty nice. Kind of red in the middle and blue on the outside too. So yeah, so our object of the day does have a couple of sort of nearby friends. At least they appear to be nearby in the sky. So 2655 and whatever this one is look sort of to be the same size, right? They sort of seem to be about the same size in the sky. So again, relatively good guess that probably their distances are about the same as well. So pretty cool. These are just these bright stars that are just completely washing out these cameras. So you get a lot of weird effects with those
things. That's what you get when you try to digitize something.
Well, they're trying to do really long exposures and all that, and yeah, bright objects like these stars are just going to saturate and cause all kinds of problems with the cameras that they use. So yeah, that's sort of a typical thing, but it certainly doesn't exactly destroy all this other stuff. So so cool, very cool. All right, well, let's go back and try to find out a little bit about what a liner type AGN is, because that's I've never heard that term before, as far as I know. So let's go down to the references here. There's a lot of them, right? So we are definitely not going to be able to look at them all, but
no.
But like I said, I like to look at sort of the latest ones and maybe some of the older ones as well. And I think one of the first things I want to do is do a search for liner. So nuclear obscuration in liners, clues for. So I'll bet you that this paper in the introduction at least I'm hoping, explain what a liner is, because that looks like some kind of an acronym, right? So let's go to this paper, which was published back in 2015. And, well, there it is right there. Low ionization, narrow emission line regions. So low ionization means that, yeah, you know, there aren't a lot of excited atoms, right? They're sort of in a stable state, right? Narrow emission lines, I think narrow emission lines mean, I think that means that they're relatively cool as well. So let's, since we're here, we might as well look at the actual paper here. So while that's loading, I'm going to take a big gulp of my HOH. We'll take a look here.
And thank you for the positive feedback, Ingrid.
Is Ingrid giving us positive feedback? Cool. Appreciate that. Yeah. All right. Nuclear obscuration. Nuclear obscuration in liners. Okay. So let's zoom in a little bit here and see. So most of the optically classified low ionization, narrow emission line regions nuclei host AGNs. However, how they fit into the unified model of AGN is still an open question. Okay. Aims of this work are to study. Yeah, this is getting into a lot of concepts that I'm just not going to dive into here. But let's just sort of see what we can extract from this. I'm not quite sure what Compton-Thick candidates are. X-ray wavelengths may be confirmed according to the X-ray and mid-IR luminosity relation. We show evidence that the dusty torus disappear when their luminosity is below a certain level. So yeah, ergs per second. So that's just a energy flux, which is, yeah, you know, that's a pretty big number there, right? 10 to the 42. That's a pretty large number. Dominant emission in the mid-infrared might be a combination of an elliptical galaxy host, a starburst, a jet, and or ADAF emission. I don't know what ADAF is. They don't really say in the abstract, but that's just the abstract. So let's, you know, what I always like to do in this case when it's just flying way over my head is I sort of like to go to the pictures and the diagrams and sort of see what's going on. Wow, so lots of references. That's always nice to see. Got a howling.
I can hear some commotion.
got a howling kitty in the background. Let's see. She's letting us know that she is here.
Oh, there's that nobody waiting on the door.
No, I don't think so. She that particular one does that from time to time. She just walks around and howls a little bit. She's got to do the howling thing. So yeah, just some plots here. So not seeing anything incredibly useful. Looks like here's some spectra, right? Here's some spectra. Looking at some quasars. So comparing this to quasars. So that's what a QSO is a quasi-stellar object, otherwise known as a quasar. So kind of interesting spectra here. Spectra, can tell us so much about not only compositions of things, but also sort of the conditions, right? How much stuff is there? What temperatures are involved?
James Dugan.
Hey there, James Dugan. Nice to see you. So wow. So we've got
yes, Ingrid. I think every single popular people on YouTube has at least got a cat. But don't be fooled. There might be some popular people that may have dogs.
I've got both, so I've got them all covered for sure. So we've got the UK, we've got Brazil, and now we have Australia and the United States. So wow, this is a worldwide live stream here. Very, very cool. So yeah, we're just looking at some spectra of our object of the day, NGC 2. What was it? 2655 or 2566? I think 2566. Oh man, I'm gonna have to go back in the chat here and find out. I don't remember these things. Okay, so yeah, so we're looking at the infrared spectrum, right? Here's a wavelength in microns, right? So these are pretty long wavelengths. Definitely, the thermal part of the infrared spectrum. So we're actually looking at what we would call heat from these things. And yeah, so pretty interesting. This paper is particularly way over my head. So again, we're just sort of looking at the pictures to sort of maybe get sort of a kind of an idea as to what they're doing. This particular object is what's called a liner. So yeah, which has very, very specific characteristics and whatnot. But it looks like what they're trying to do is sort of do a comparison here, right? And show that, at particular wavelengths, there's some kind of a feature that they seem kind of interested in, right? That looks like around 25 microns or so. But yeah, doing a comparison here, it's like I'm not seeing a lot of similarities. So yeah, don't know. Here's some more plots. Don't really know what that's going on there. I can definitely say that these are extremely colorful plots. There is no doubt about that. So discussion. Here's some more spectra. Best fit to clumpy models. So yeah, I mean, as with most work in astronomy, you have data and then you have models, and your models have all kinds of variables, all kinds of parameters that you can set and vary, and sort of watch, right? And you can change these parameters around until they sort of fit observed data, and then you can sort of kind of infer that, okay, well, if the data from the model matches the actual observed data, then maybe the parameters that I have set for the model are the actual things that are going on with this object. Now, that may or may not be true, right? You got to remain pretty skeptical about these kinds of things. But one of the things that most of the papers do is, and they may not say this extremely clearly, but they'll give you an idea about how confident they are in what they think they're doing and stuff. So that's sort of my guess as to what they're showing here. Is it's like, here's the models, here's the data. Are they close? Are they far away? You try to do some kind of an objective evaluation, right?
Yes.
Jet emission. So conclusions. I'm not quite sure what an SB dominated spectra is, but there it is. A silicate optical depth. Wow. Yeah, this is very, very much flying over my head. But yeah, they have some conclusions here. Compton thick in X-rays. So yeah, I'm not quite sure what that means. Yeah, don't know. Dusty material absorbs continuum radiation both in the UV optical and the X-ray, and therefore the dusty torus might also be responsible for part of the X-ray obscuration. Okay, so maybe they're not seeing a lot of X-rays. Yeah. Absorption comes from timescales. Wow, okay. Yeah, all right. Well, at least we sort of know what liner means now. Although low ionization, narrow emission line regions, yeah, like I said, that to me means that there's low energy and kind of low temperature too, because I think the wider emission lines sort of imply like a higher temperature as well. So yeah, wow, that's just flying way over my head for sure. Let's go
At least
back
doesn't
here.
give you a ibuprofen.
No, it isn't that. I'm enjoying this way too much for that. But let's just sort of see here in the first few if there's anything incredibly interesting. Here's some radio emission at 15 gigahertz. Kind of cool. So this object, wow, they've really been looking at this thing quite a bit. Multi-wavelength photometry. Might be a little bit interesting. Let's look at that one really, really quick. See if there's anything. Let's see if we can find our object of the day, right? NGC 2655. We'll just do a little search here. Go to archive.org. It looks like, I mean, I know I say this every time, but it's just absolutely mind-blowing how much work goes into all of this. And these people are just working like crazy, right? just absolutely amazing. I've got a huge amount of respect for these authors who put so much effort, right? This is a 31-page paper, right? And I thought I saw a plot showing all the different wavelength bands. Maybe that's what's coming up here. It's pausing on me as if it's loading a large graphic. Yeah. So, yeah, a lot of wavelengths there, band passes, as they say, going from, you know, almost 0.1 microns all the way out to, you know, like 10,000 microns. So, you know, that's covering a large part of the visible spectrum, well into the infrared, into the radio, right? I think, yeah, 10,000 microns is 10 millimeters. So yeah, not quite into the radio, right? They're still into the millimeter range, but that's pretty amazing. That's quite a bit of coverage there. But there's imagery. So yeah, you know, they're just sort of, you know, collecting this data, you know, from different spacecraft and different surveys and whatnot. The Sloan Digital Sky survey here. So they have imagery, they have photometry. Okay, yeah, so here's all the wavelength bands, right? So it actually goes from the ultraviolet through the millimeter. Wow. That is quite a collection of data. Pretty amazing. Pretty amazing. Let's see if there's any, with this size of a picture, yeah, you know, and they go through every single survey and talk about, you know, what data is there, what data was extracted. Wow, it's just an amazing amount of work, right? Mm-hmm. There's a photometry pipeline, so you can get into that. Wow. The comprehensive and adaptable aperture photometry routine. Wow. And if you want to look at the actual source code, they've got it here. Very cool. I should take a look at that, compare it to the code, you know, that I have to do my photometry. Maybe I'll learn something. So there's obviously a galaxy of some sort that they're probably, okay, yeah, they're doing star removal. So that's kind of cool, kind of interesting. It's just amazing how much, you know, like I've said many, many times now, it's really, really incredible how much work goes into all this stuff. Sky subtraction, aperture fitting. Wow. Aperture combining. These are all, you know, the different surveys and whatnot, right? Wow. Amazing amount of work. Wow, what's going on here? Okay, so this is how the software determines the aperture noise in the map. Interesting. Okay. Yeah, that's kind of an interesting way of doing it. It looks like, you know, they sort of avoid the target here and just sort of, you know, sample around, measuring the noise, you know, from all of these areas. And yeah, you know, you get an average noise. Yeah, that works. Cool. photometry flagging, supplementary photometry. Wow, again, you know, just incredibly thorough. Photometry validation, uncertainties. It's always, you know, it's always a good sign when a scientist, you know, makes a measurement and then tells you how good they think the measurement is, and that's what, you know, the uncertainty here is. And so that's always nice to see that, because, you know, science isn't certain about much of anything. You know, science is a process of learning more. Anybody, any scientist, you know, who says, you know, that they're sure, that's a red flag. That's a big red flag. You got to remain skeptical, not cynical, right? Skeptical. You got to take a good hard look at things, but, you know, keep an open mind and stay curious, for sure. So yeah, see, this is all the uncertainty in the measurements. Very cool. All right. Yeah. Wow. This is just an enormous, enormous amount of work. Wow. Oh, you know, we didn't look for our target. I don't know if it's going to be here or not, but let's find out. 2655. Nope. Not there. At least not in that form. Not in that form. It could be under another name. Let's see if there's any lists at all. Yeah, it doesn't look like it. So, you know, since there aren't any lists, which I'm not too surprised, it's probably listed somewhere else, right? You know, you have to go online and find it that way. But, you know, they're talking about 875 galaxies. So, yeah, it's probably in a list somewhere else. Here we go. Full photometry tables are available in electronic form, and actually over at CDS, which is the same place that Simbad or Anonymous FTP. I wonder if we can just go here. I don't think so. That doesn't look like a long enough reference to find this specific paper. There is a Dustpedia archive, though. Well, let's try that. Dustpedia. Welcome to the Dustpedia archive. Data. Galaxy name. Well, let's try it. It was 2566, right? Man.
You always get hit with a neuralizer.
2655. 2655. 2655. There's too many numbers there. Okay, so let's do a search and see if it comes up with anything. Ah, it does. Wow, quite a bit. Cool. Okay, these look like they're all FITS files. Don't know if they're images or tables or whatnot, but yeah. So oh, okay. Well, here's some photometry cutouts. What's that? Oh, okay. Well, that's a very, very largish file, but it's downloading here. We'll take a look here just for fun. I like to see what these things are. So we'll show in the folder here. So we'll go to the right place, and then we'll Okay, yeah, let's it's a little big, but let's open it up. So this is just images of it from, you know, the various surveys, right? So let's maximize this so we can see. So yeah, so you know, the Digital Sky Survey, 2MASS, WISE, Spitzer, PAX, Spire. Cool. And yeah, you know, I mean, that is one of the really awesome things about observing these objects at different wavelengths is that they you know, almost look like completely different objects, right? You know, if you look at the 2MASS, which I think is some kind of an infrared survey, right? It sort of looks like that. I think Spire might be X-ray. I can't be sure about that. But yeah, I mean, you know, I mean, it looks different, right? Um, so yeah, you know, we can always gather a lot of information, you know, by looking at the same object in different ways, right? It's like changing your perspective on stuff. So yeah, that's kind of cool. Kind of cool. But yeah, it looks like there's quite a bit of information here for sure. Let's go to photometry. Despedia, main photometry. Oh, okay. That's yeah,
That's usually not necessary.
yeah, that's not going to help us at all. All right. Well, I'm going to go back to where we were here. Where were we? There we go. Back to the references. I'm going to get rid of that. And let's let's go back a little bit more. Let's go back to the earliest one, right? These Simbad has been nice enough to list all of these in chronological order. So let's go back to the earliest paper that mentions this object. 6, the Astrophysical Journal, from E.P. Hubble himself. So, you know, back in 1926, they didn't actually realize that these were galaxies yet, right? They still called them nebulae. They really didn't have any idea what they were, except they were fuzzy. So, but you can see, wow, there's a 40-year gap between the first one and the second one here. So yeah, let's take a look and see. We may get something, we may not. Oh, we do. Wow. So this is from Edwin Hubble himself back in 1926, publishing something, extragalactic nebulae, back in 1926. So this contribution gives the results of a statistical investigation of 400 extragalactic nebulae. Determine total visual magnitudes. Classification, luminosity relations, figuring out how to get distances. Wow, so this is by the man himself. So he was trying to classify these. That's pretty cool. Planetaries, diffuse. Okay, yeah, so elliptical. So yeah, maybe by then they were sort of getting a little bit of a clue that maybe they were extragalactic, right? I mean, that obviously implies that. So, but maybe still not exactly sure what they were. Pretty cool. Let's see if okay. So yeah, here's I don't know if, well, I mean, obviously he is sort of laying out a classification system for all these objects, right? Planetary nebulae, diffuse nebulae, and then the elliptical galaxies, the spiral galaxies, and irregular galaxies. So pretty cool. So yeah, wow, okay, well, maybe they had a pretty good handle on this by then. I didn't think that they came up with the idea that they were like really far away until later, but what do I know?
I think it's kind of like a bit crazy the way that I'm looking at the at your mouse and stuff. That they actually not just digitized it, but they actually had like that text-based recognition technology. So I think like a simple page search would be good.
Oh yeah, 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 cool, nice. Yeah, well, we can definitely do that. Now, of course, these are all photographs, right? So there weren't any CCDs, there weren't any like electronic much of anything, right? The telescopes um, um, ran electrically, but in terms of detectors and stuff, these are all photographic emulsions, and of course these are copies of those things. And I recognize a few of these. M82, right, from 1926-ish or so. Pretty cool. Pretty nice. So yeah, let's try to find this guy, 2655. But if those things are all handwritten, we may not. No, it's not. It's not finding it. Wah. So what have we got here? Oh, okay. Irregular nebulae. NGC 4214 from the 100-inch reflector, March 18th, 1925. Wow. So, oh, okay. So, oh, neat, neat. So this is I'm going to zoom out a little bit here, and let's try to rotate this too. Yeah. So this is an image and a spectrum, right? So pretty cool, pretty cool. Not much to see in the spectrum here, but probably relatively useful, at least at the time. I'm not really seeing a lot of detail, right? The how these spectra work is that now this axis is the wavelength, right? And then what you're seeing here, right? Like this feature here, this is the spectrum of this bright um, um, feature here. Apparently, there's something really, really bright in here that I can't really see inside of the picture, but there's some kind of bright object there. And yeah, we're seeing the spectrum of that. And again, here, there's some kind of object out here that we're really not seeing much of. Am I going to have to rotate this all the way around? I think so. So bear with me while I rotate this back. to where it was. And yeah, I'm noticing the time too. So we'll get through this, and then we'll call it a live stream. Let's see if there's anything else here. So yeah, he did a seriously big survey. So what was it? 2655. I'm looking to see if I can find it, because I'm going to have to do it by eye here. See if we can find it at least. I think this is some kind of a distance measurement. Oh, I'm not quite sure what m sub t is. We'd have to go to the description of the table. Is it table 1 or table I? Oh, we're just getting that. Well, at least these are in numerical order here. So yeah, this was supposed to be like an E. Well, no, it's not an elliptical, right? It's a spiral. At least that's what we think they are now. So let's go past the ellipticals. I'm going to get rid of this. Here's the barred spirals, at least what he's calling barred spirals. I'm not seeing it there, so he didn't think that they were barred spirals. Normal spirals. There he is. NGC 2655 right there. So yeah, I'm not quite sure what m sub t is. Log d, I think, is some kind of a distance modulus of some sort. We'd have to look that up. But yeah, he's calling it an SA, which I think is pretty much what Sinbad is still calling it to this day. So almost 100 years later, it's still considered an SA. Yeah, I'm sort of, I'd like to find out what an m sub t is, but let's see if we can actually, let's see if we can go to the top here of the paper, and I will sort of click inside here. And okay, one of 3, table 1, table 1, table 3. Wow. Okay. Let's see if we do this. I'd like to know what m sub t is. Let's go back up to the top. Just do a search for table and see if we can get a E5 nebulae, and from these were derived mean correction tables. The data listed in tables 1 through 4, in which the NGC numbers the total magnitude. Okay, so that's a magnitude. And, oh, okay, so it's the logarithm of the maximum diameter in minutes of arc. Now, why he would do a logarithm, I'm not exactly sure. But, okay. Whatever he wants to do, he can do. He is Mr. Hubble. So, yeah, he can do whatever he wants. So cool. Okay, so that's a magnitude, and this is the apparent size in a weird logarithmic scale. Not quite sure why he decided to do that. 2655. I'm really surprised that it's not coming up in the search. All right, well, so be it. Anyway, he definitely observed this. He definitely categorized it. Can we get back down to that guy? where is it? To the ellipticals. Getting there. Barred spirals. Normal spirals. Here he is. 2655. So magnitude 11.1 and log.
When you do that search function in that PDF, I think it was like a big paper, and I think it's taking a little while indexing and finding it.
Well, I think maybe you're right. And I'm just hurrying a little bit too much. So if I take 0.6 and do an inverse log, which is going 10 to the 0.6, I get 3.98. So it's about 4 arc minutes in size. And I don't know if Simbad actually shows the size here. Sometimes it does, sometimes it doesn't. In this case, it's not. So, okay. Well, very cool, though. Very cool. Let's see. This is table 3, so this is the same spiral list. He did quite a few of these objects. Pretty amazing. Sat down, probably with a ruler and worked all this out. Because the pixel scale here is in like degrees per inch. So yeah. Okay, so here's a distribution of magnitudes, right? So for the spirals, I'm going to zoom in again a little bit here. There were 2 between magnitudes 8.1 and 8.5, 4 of them between 8.6 and 9. So yeah, this is an interesting way, to sort of understand, the distribution of magnitudes, and according to type, right? Morphological type. Here's ellipticals, and here's all the spirals. So pretty cool. Pretty cool. Pretty cool. Wow. He even made plots. Wow. So this is just a histogram. This is basically just a histogram of the data that was in the table. And so yeah. It's interesting that there's a drop off here as it gets fainter, right? And that's probably because he's just not detecting as many. I mean, this chart probably goes, way up off the top of the chart, but we're seeing the limitations of the detection, right, of the photographs. So that's kind of cool. And so here's a relationship between the size and brightness, right? So the bigger the size, the brighter the object. Makes sense. That's great. He's making these plots, right? I mean, he's having to do this all by hand too. Pretty incredible. So here's for the looks like okay, so the big ellipticals and then some of the spirals, right? So yeah, he can sort these by morphology too. Very, very cool. See, there seems to be a clumping here, right? Seems to be, yeah, kind of neat. Kind of neat. we could actually do, the same kind of thing today, but using modern data if we wanted to. Might be an interesting exercise. Not quite sure what this table is. Effects of orientation. So yeah, just yeah, very cool. Again, I mean, very thorough, right? It's just an amazing amount of work. Amazing. Well, cool. Very cool. It's always really, really neat, to see these early papers, right? Let's just do really, really, really quick because I know we're running really, really long here. Let's just see what it looked like in 1966. In 66, ooh, I don't think they were doing any kind of electronic detection yet. But again, this I think is just an atlas. It's probably going to sort of be the same kind of thing, where it's just, different types. But it might be interesting to see a picture of it. So we didn't really get a picture of it from Hubble, but maybe we'll get a picture here because it's supposed to be an atlas. It's taking a long time to load, so it's probably really big. Come on, you can do it.
Or it probably just like stopping mid-transfer. You gotta watch that sometimes.
Yeah, no, it's still going. It's just taking its time. I think it's just a big file. In science, you have to be a little patient
Hey, good night,
sometimes.
Ingrid. Thank you for the positive feedback and take care.
Yeah, thanks for coming in. It was great to see you in the chat. Very, very great. Come on back whenever you like. You are very, very welcome here, and share this around. Tell your friends. Tell them to come in. We'd love to have everybody here, for sure. And this is sort of what we do. I'm following my nose, and I'm sharing that experience with all of you. Just here to share a passion. That's about it. Not really here to teach anything or anything else. Just following my nose and sharing it with all of you. That's as much as I can possibly do. Wow, this is taking a long time to load, but now that it's so close, I'm sort of really wanting it to finish. Oh, come on, you can do it. I know you can do it. It's probably a bunch of pictures, right? It's almost there. I'm going to take another big gulp of this HOH here. Running really, really late. Oh, yeah, 77 pages. Wow. Oh, so Halton Arp. Cool. So Halton Arp is a galaxy dude for sure. So, all right, well, let's immediately go to the search here and do 2655 and see if it comes up at all. Yeah, I'm not seeing anything. Yeah, 338 photographs. So yeah, this is just all pictures in the following 57 pages. So all right, well let's hope that maybe he ordered this by NGC number. Can we hope that? No, it doesn't look like it. It looks like it's a photo number, 73, 74, 75, 76, 77, 78. Bummer. How are we going to find out which one is which? Maybe there's a table. Let's go to the top of this list. Imaging all of these with photographic plates, you know? Wow. Come on. I'm going to try to go to the top, right to the top here, and see if there's a list. Come on, you can do it. You can do it. You can do it. Okay, it's not here. So let's go to the bottom, to the end, and see if there's any. Here we go. Designation. This is table 3. Table 2. Sorry, I'm having to turn my head sideways to sort of see this. You can do the same. It's a, you know, I mean, when you're an astronomer, you also have to be a contortionist of sorts. But let's see if, because I'm seeing, I think I'm seeing a number here. You see that? So let's try to find 2. There it is, 2655, right there, right? Let's zoom in on that, make sure, because that will probably give us the plate number, right? Yeah, there's 2655 for sure. Okay, so, oh, number 225. 225? That makes sense? I think that makes sense. Ooh, let's try. If this fails, I'm just going to quit for now. So 225. I mean, what we should see is sort of a round fuzz, right? 283. We're looking for 225. Come on. 246. We're getting close. 234. What's that, Bobby?
Is that supposed to be 255 or 235?
225. Don't mess with me. Don't mess with me. I'm already confused enough. All right, there it is. There it is. Now, we can confirm this, right? You see how there's the galaxy here, then some stars up here. Let's go back to sort of the modern picture. See, there they are. It's just flipped, right? So here's the bright one. Here's 1, 2, 3, 4, right? And if we go here, we're seeing 1, 2, well, sort of. Things might have moved, right? You know, stars move. I'm sort of thinking that that's it, though. Guess maybe that's kind of hard to tell. Kind of hard to tell if we can confirm this or not. The faint one is sort of away from the galaxy there. Oh, and this faint one's towards it. So, yeah, I can't be absolutely certain, but it sort of looks like it. Don't know if it is, but look, I've gone way over time, so I like to keep these to an hour-ish or so, and we're definitely way over. So for now, let's end this live stream. So I'm really glad that you all were here, and yeah, looking at this kind of interesting, well-studied galaxy for sure. So, all right, well, cool. I guess I'm going to get out of here for now. I'm just looking at the chat. Cool. Very, very nice. All right, I'm going to get out of here for now. So take care, everybody. I will see you in, 22 hours and 25 minutes. I will be back. So take care. Make sure to subscribe if you haven't already. Hit the thumbs up if you like. Make some comments. Share this around. Let's do it again tomorrow. 2 hours UTC. All right. Take care, everybody. See you later. Bye.
Right.